Hi, this is Mark from GradeHub. I'm here with Jennifer Balogh, a testing expert and author of A Practical Guide to Creating Quality Exams. If you missed our last segments on reviewing overall exam statistics and percentiles, check those out. With this installment, we're discussing how to determine if your exam questions are good ones. Jennifer, thanks for joining me.
Thank you, Mark.
So Jennifer, I think most educators have heard of an item analysis, but I often see really a ton of confusion, even from the administrators who run testing centers and instructors who are actually administering exams. So can you give us some general guidelines on how to interpret these statistics?
Sure. What you want to look for really in terms of your items is how difficult is an item, but also how well is the item's ability to discriminate a high-performing student from a low-performing student, someone who actually mastered the material from someone who didn't. And there are some great statistics that GradeHub provides that allow you to be able to look at a glance at items and really try to understand whether that item is functioning well or not with regard to whether it can discriminate high performers or low performers. And the idea is you want students who are doing well and mastering the material to get an item correct, and you want students who are not mastering the material to get an item wrong. So that's an ideal situation for an item, gives you the most information, is when students who are high performers get it correct and students who are low performers get it wrong.
So like our previous installments, can we go through the item statistics here in a GradeHub report to see how you interpret this one report, which we call our item matrix tab?
Sure, and I have to say, I think this is my favorite tab. I just love the information here. Basically, what it's showing you is the measures discrimination, whether an item can, and when I use that word, I know it's a very overloaded term, but what I'm really talking about and what is discussed in the testing literature is an item's ability to discriminate the knowledge and skills of a test taker. And the main statistic that's used in order to quantify an item's ability to discriminate is a point-biserial. What a point-biserial is simply a correlation of responses on this item, whether the person got it right or wrong, correlated to their overall score, their overall test score. The idea being, if somebody is a very good student and they tend to get most items on the test correct, you would expect that they would also get this item correct. In contrast, someone who's failing miserably on the test because they just haven't shown up for class and they don't know the material, they're not going to be performing well on the overall test, and you would expect them also not to perform well on given items. And so because you're correlating these two, the higher the correlation, the higher this item is correlating with what we're thinking of as general knowledge of the course material. So higher point-biserial, and when it's a point-biserial, it's just comparing item responses which are correct or incorrect. It can be one of two things. It's a 0 for incorrect or 1 for correct, compared to a more continuous scale, which is the score on the test. That's just a fancy way. A point-biserial is simply a fancy way of saying a kind of correlation that deals with one element that's dichotomous with zeros or ones. So really what it is a correlation. And the higher the correlation, the higher that item is at discriminating high performers from low performers. What you typically are shooting for is something, well, that's something that's positive. When you're going into negative numbers for point-biserial, it's kind of the reverse of what you're expecting. In that situation, low performers might be getting this item correct, and high performers are not. You know that there's a big problem maybe with the key, or simply the information is in the question is being conveyed in a way that high performers aren't getting it right. You know there's a problem there. So
Yeah.
generally, you want to keep your point-biserials positive. When you're in the professional testing field, we really shoot for items that have a point-biserial of 0.3 and above, which is pretty aggressive. Now, because your instructors are not actually going to be selling tests, that's not the point of these, that can be relaxed quite a bit. I've seen different numbers where people think that 0.15 and above is good. Others that are saying anything that's positive is good. Anything that's 0.2 is good. There's really no set number, but generally the guidelines that GradeHub has here in terms of if you're below 0.15, you could probably improve that item in terms of its discrimination. In between the range of 0.15 and 0.3, it's okay, but it probably could be improved in another test if you're going to reuse items, or you could think about how that could be better if you maybe tweaked that item a little bit and improved it. And then anything that's 0.3 and above is absolutely fine in terms of discrimination.
Oh, great. That's
Yeah.
interesting. And then, can you go a little bit over our matrix here? We're showing the exam at a high level. It's an item analysis. When we're showing the difficulty levels and also the discrimination.
Right. So across the top, so you've got the difficulty. And the difficulty here, again, is represented as proportions. And that's very typical in the testing field to show difficulty in that way. It's basically the proportion of students that got the question right out of all of the students who took the test. So, excuse me, anything that's 0.85 up to 1.0, you can just think of them as 85% of the students got that item correct. So it's pretty easy. In the mid-range, 50% to 84%, those are represented as proportions, 0.5 to 0.84, got the item correct. So those are the items where I feel like quite a few people have missed them. So those are in the medium range. And that's a great range for items to be in because you're getting a lot of information about your students when items are in that range. Then you have the harder items that are below 0.5, and that's just showing you that students just are not knowing the material. Generally in professional testing, we try to steer away from items that are super hard at proportions of 0.3 or below. Because you really want to target items that have, if everybody's missing an item, you're just not getting as much information out of that item. Again,
Yeah.
you might be in a situation where you want to make sure that some content is covered, but it is a good idea to review the items that are coming in that are extremely difficult.
Whenever people talk about p-values, is this the same thing as a p-value?
That's right. That's the same thing as a p-value, is the proportion here.
Interesting.
And that's why they call it a p.
Yeah, sometimes I hear p-values. I'm like, wait a minute, what does that mean? So there,
Yeah.
that.
That's the same. When I first was introduced to the field, I wondered, okay, what is this strange p-value? That's all it is the proportion of students that got an item correct versus all of those that took the test.
And then we also plot by discrimination.
Yeah. So down in the column on the left, you see that you've got this nice grid where you've got difficulty across the top, and now along the side you've got discrimination from the poor discrimination at 0.15 to the good discrimination at 0.3 to 1. And so that represented in a grid is a great way to look at how your items are performing in general. So generally when you're in this poor column, you want to be looking at those items, seeing if next time you can improve them. Sometimes if they're performing and they're performing so bad that they're negative, you should, I recommend, consider taking them out of the test
Okay.
and scoring. because usually if it's negative, something wrong is going on in that case.
So
It's
that
not,
in that case, you would change the weight to 0 then and throw it out.
yeah,
Okay.
that's what I would do. You have to be careful with that kind of performance just because you might be measuring something that's outside of what the intent was.
And this, if you were to look at this grid overall, you would say we had a well-written test and it was really easy.
Yeah, absolutely. And it's nice to be able to see which items had good discrimination that were easy, but also in the medium range. And this can help also as you're moving forward to say, okay, maybe I need more items that are just a little bit more difficult. And you can look at the spread of your items and how their performance looks graphically to help you write items in future exams.
So here is our item analysis report in GradeHub. And, I was wondering if you could go through just question 2 here that I've highlighted and give us some of your insights on how you would read all the information that's here on this graph.
Sure, there's a lot of great information here. First, on number 2, you can see all the numbers in terms of the distribution of the score responses. So you can see that 15% of the students responded with A, and you can see that graphically in the chart above. So it's a great visual to help you see what the pattern of response was. I also like how the correct answer is in bold, so you can see that most people responded D, and that was the correct answer. That's very easy to see. Then you have RPB, and what that's doing is just showing you the correlation for the point-biserial. That's why it's PB, point-biserial. The reason that it's an R is because traditionally correlations are represented with R. So that's what that means. And basically, again, what this is showing you is the item's ability to discriminate those who have mastered material from those who have not. And the higher this number is, the better. Generally, you don't want that number to be negative, or anything below 0.15 should probably be looked at. The other way that you can visualize this information, which are in the graphs above, and it says upper 25% and lower 27% and lower 27%. Why 27? It has to do with the fact that a lot of these techniques for estimating discrimination came about before there were personal computers. And frankly, a correlation took a lot of effort to compute by hand. And so researchers came up with different ways of how to estimate that in a quick way. And one technique used the upper 25% of students from a class compared to the lower 25% of students. And that's why you see that. And you can see this graphically here. So the upper 27%, they're responding with the correct answer of D, which is what you want to see. And then the lower 20%, some of them are responding D, but importantly, others are not. And that's exactly the kind of pattern that you want to see. And that's why it's reflected in a very solid correlation score here of 0.465. The next column is very interesting. What that's showing you is alpha, or the reliability of the test overall. So you can see the reliability of this test, which is very high. It's 0.799. And what the alpha minus means is that if you were to calculate the reliability of this test without this particular item, what would the reliability be? And generally, you'll notice that the numbers are going to be a bit lower, and that's simply because you're dealing with one item less in your computation. What you don't want to see is a huge bump in your reliability when this item is gone. It's kind of an indicator that this item is not doing its job. And then finally, in the right-hand column, you've got the 27% low and high. That's giving you the numbers behind the charts that you're seeing up above. Again, it's a great way to look at information at a glance. What you want to see in this case is you would want to see high numbers on the right-hand side and lower numbers on the low side, on the left-hand side in that ratio, because that's telling you that the item is doing its job. The the high performers are performing well on this item, and those who are not so strong in terms of their knowledge recovering in this test are not performing as well. That's exactly what you want to see.
Well, that's awesome. Now, I was wondering if we could go through one more test question and one that, we're not seeing the same, everything's perfect. And so I highlighted question 16. I was wondering if you could just give some of the differences that you see from question 2, which you looked at and said was a high performing test question versus one that's lower performing.
Sure. So let's look at this one. It seems that 85% of the students who are exposed to this item are responding C, which is the incorrect answer. That doesn't necessarily by itself mean that it's a terrible item. If the majority of those students who were answering C were the low performers in general. Where you can see the problem is in the correlation numbers. So they are the point-biserial, which is negative. And you can also visually see what's going on when you look at the upper 25%. And you can see that the upper 25%, most of those students are answering C as well. And that's not the pattern that you want. You don't want the high performers to be fooled by this question, because then the item is not doing its job. So this is a great graphic where you can see the upper 20% providing the wrong answer. So you know, and because of the correlation is negative, those two pieces of information are having you consider maybe you need to look and make sure that this item is keyed correctly or try to identify a problem with this item. The other corroborating information here, again, to identify this item as having a problem is the alpha actually goes up when this item is removed from the test. And so that's an indication that this item is not doing its job well. And then visually, you can see that in the chart, but then looking at the number with the 27% low and high, again, you can see right in front of you that the high performers, only 20% of those are getting the item correct, which is not the pattern that you want to see.
Okay, great. So thanks, Jennifer, again for sharing all of your insights. To learn more about GradeHub, visit us or schedule a demo at our website at gradehub.com. Thanks, and thanks for joining us.